Mars and Its Canals by Percival Lowell, Part 2, Non-Natural Features, Chapter 15, The Canals. From the detection of the main markings that diversify the surface of Mars, we now pass to a discovery of so unprecedented a character that the scientific world was at first loath to accept it. Only persistent corroboration has finally broken down distrust, and, even so, doubt of the genuineness of the phenomenon still lingers in the minds of many who have not themselves seen the sight because of the inherent difficulty of the observations. For it is not one where confirmation may be summoned in the laboratory at will, but one demanding that the watcher should wait upon the sky with more than ordinary acumen. This latter-day revelation is the discovery of the canals. Quite unlike in look to the main features of the planet's face is this second set of markings which traverse its disk, and which the genius of Schiaparelli disclosed. Unnatural they may well be deemed, for they are not in the least what one would expect to see. They differ from the first class not in degree but in kind, and the kind is of a wholly unparalleled sort. While the former bear a family resemblance to those of the earth, the latter are peculiar to Mars, finding no counterpart upon the earth at all. Introduction to the mystery came about in this wise, and will be repeated for him who is successful in his search. When a fairly acute-eyed observer sets himself to scan the telescopic disk of the planet in steady air, he will, after noting the dazzling contour of the white polar cap and the sharp outlines of the blue-green seas, of a sudden be made aware of a vision as of a thread stretched somewhere from the blue-green across the orange areas of the disk. Gone as quickly as it came, he will instinctively doubt his own eyesight, and credit to illusion what can so unaccountably disappear. Gaze as hard as he will, no power of his can recall it, when, with the same startling abruptness, the thing stands before his eyes again. Convinced, after 3 or 4 such showings, that the vision is real, he will still be left wondering what and where it was. For so short and sudden are its apparitions that the location of it is dubiously hard. It is gone each time before it has got its bearings. By persistent watch, however, for the best instance of definition, backed by the knowledge of what he is to see, he will find its coming more frequent, more certain, and more detailed. At last, some particularly propitious moment will disclose its relation to well-known points, and its position be assured. First, one such thread, and then another will make its presence evident, and then he will note that each always appears in place. Repetition in situ will convince him that these strange visitations are as real as the main markings, and are as permanent as they. Such is the experience every observer of them has had, and successes depend upon the acuteness of the observer's eye and upon the persistence with which he watches for the best moments in the steadiest air. Certain as persistence is to be rewarded at last, the difficulty inherent in the observations is ordinarily great. Not everybody can see these delicate features at first sight, even when pointed out to them, and to perceive their more minute details takes a trained as well as an acute eye, observing under the best conditions. When so viewed, however, the disk of the planet takes on a most singular appearance. It looks as if it had been cobwebbed all over, suggestive of a spider's web seen against the grass of a spring morning. A mesh of fine reticulated lines overspreads it, which with attention proves to compass the globe from one pole to the other. The chief difference between it and a spider's work is one of size, supplemented by greater complexity, but both are joys of geometric beauty. For the lines are of individually uniform width, of exceeding tenuity, and of great length. These are the Martian canals. 2 stages in the recognition of the reality confront the persevering plotter. First, the perception of the canals at all, and second, the realization of their very definite character. It is wholly due to the lack of suitable conditions that the true form of the Martian lines is usually missed. Given the proper prerequisites of location or of eye, and their pencil-marked peculiarity stands forth unmistakably confessed. It is only where the seeing or the sight is at fault that the canals either fail to show or appear as diffuse streaks, the latter being a halfway revelation between the reality and their not being revealed at all. Much misconception exists on this point. It has been supposed that the improved atmospheric conditions simply amount to bringing the object nearer by permitting greater magnification without altering the hazy look of its detail. Not so. They do much more than this. They steady the object as much as if a page of print from being violently shaken should be suddenly held still. The observer would at once read what before had escaped him for being a blur. So it is with the canals. In reality, pencilings of extreme tenuity, the agitations of our own air spread them into diffuse streaks, an effect of which anyone may assure himself by sufficiently rapid motion of a drawing in which they are depicted sharp and distinct, when he will see them take on a streaky look, as the writer has observed them under both aspects, and has seen them pass from the indefinite to the defined as the seeing improved. He has practical proof of the fact, and this not once but an untold number of times. Atmospheric conditions far superior to what are good enough for most astronomic observations are needed for such planetary decipherment, and the observer experienced in the subject eventually learns how all-important this is. Under these conditions, the testimony of his own eyesight upon the character of these markings is definite and complete. And the first trait that then emerges from confusion is that the markings are lines, not simply lines in the sense that any sufficiently narrow and continuous marking may be so called, but lines in the far more precise sense in which geometry uses the term. They are furthermore straight lines. As Schiaparelli said of them, they look to have been laid down by rule and compass. The very marvel of this sight has been its own stumbling block to recognition, joined to the difficulty of its detection. For not only is the average observatory not equipped by nature for the task, but what is not good air often masquerades as such. Trains of airwaves exist at times so fine as to confuse this detail, or even to obliterate it entirely, while at the same time they leave the disk seemingly sharp cut, with the result that one not well versed in such vagaries thinks to see well when in truth he is debarred from seeing at all. When study of the conditions finally ends in putting him upon the right road, the sight that rewards him can hardly be too graphically described. Next to the fact that they are lines, definiteness of direction is the chief of their characteristics to strike the observer. The lines run straight throughout their course. This is absolutely true of 90% of them, and practically so of the remaining 10%, since the latter curve in an equally symmetric manner. Such directness has I know not of what immediate impressiveness. Quite unlike the aspects of the main markings, which show a natural irregularity of outline, these lines offer at the first glance a most unnatural regularity of look. Nothing on earth of natural origin on such a scale bears them analog. Nor does any other planet show the like. They are, in fact, distinctively Martian phenomena. This is the first point in which they differ from the markings we have hitherto described. The others were generic planetary features. These are specific ones peculiar to Mars. Equally striking is the uniform width of each line from its beginning to its end as it stands out there upon the disk. The line varies not in size throughout its course any more than it deviates in direction. It counterfeits a telegraph wire stretched from point to point. Like the latter seen afar, the width, too, is telegraphic, for it is not so much width as want of it that is evident. Breadth is inferable solely from the fact that the line is seen at all, and relative size by difference of insistency. Indeed, the apparent breadth has been steadily contracting as the instrumental, atmospheric, and personal conditions have improved. All three of the factors have conduced to such a maceration, but the middle one the most. For the airwaves spread every marking, and the effect is relatively greatest upon those which are most slender. As the currents of condensation and refraction pulse along, their denser and their thinner portions refract rays on either side of their true place, and thus the same time confuse a marking and broaden it. The consequence is that the better the atmospheric conditions, and the more that has been learned about utilizing them, the finer the lines have shown themselves to be. Herein we have a specific intrinsic difference between the fundamental features and the lines. The main markings have extensions in 2 dimensions, the latter in 1. Distinctive as they thus are, they have, in keeping with their appearance, been given a distinctive name, that of canal. Useful as the name is, and, as we shall later see, applicable, it must not be supposed that what we see are such in any simple sense. No observer of them has ever considered them canals dug like the Suez Canal or the Phoenix-like Panama one. This supposition is exclusively of critic creation. Their precise width is not precisable. They show no measurable breadth, and their size, therefore, admits for certain only of an outside limit. They cannot be wider than a determinable maximum, but they may be much less than this. The sole method of estimating their width is by comparison of effect with a wire of known caliber at a known distance. For this purpose, a telegraph wire was stretched against the sky at Flagstaff, and the observers, going back upon the mesa, observed and recorded its appearance as their stations grew remote. It proved surprising at what great distances a slender wire could be made out when thus projected against the sky. The wire in the experiment was only but 0.0726 of an inch in diameter, and yet could be seen with certainty at a distance of 1,800 feet, at which point its diameter subtended only 0.69 of a second of arc. How small this quantity is may be appreciated from its taking more than 90 such lines laid side by side to make a width divisible by the eye. Such slenderness at the distance of Mars would correspond, under the magnification commonly used, only to 3/4 of a mile. Theoretically, then, a line 3/4 of a mile wide there should be visible to us. Practically, both light and definition is lost in the telescope, and it would be nearer to the mark to consider in such case 2 miles as the limit of the perceptible. With a planet nearer than this, as is often the case, the width which could be seen would be proportionally lessened. Perhaps we shall not be far astray if we put 1 mile as the limiting width which could be perceived on Mars at present, with distance at its least and definition at its best. That so minute a quantity should be visible at all is due to the line having a sensible length, and by summation of sensations causing to rise into consciousness what would otherwise be lost. A stimulus too feeble to produce an effect upon a single retinal rod becomes recognizable when many in a row are similarly excited. The experiment furnished another criterion of importance as regards to the supposition that the lines on Mars are illusory. It showed that the brain-begotten impressions of wires that did not exist could be told from the real thing when the wire subtended 0.69 of a second of arc or more. That below this, the outside stimulus was too weak to differ recognizably from the optic effects otherwise produced, while when the real wire was diminished to 0.59, it could not be seen at all. Now, the majority of lines on Mars so far recognized and mapped lie in the strength of impression far above the superior limit of 0.69. To one versed in Martian canal detection, there is no possibility of self-deception in the case, the canals being very much more salient objects to an expert than those who have not seen them suppose. For it must not be imagined that, when one knows what to be on the lookout for, they're the difficult objects they seem to the tyro. Just as the satellites of Mars were easily seen once they were discovered, so with these lines. A mile or 2 we may take, then, with safety, as the smallest width for one of the lines. The greatest was got by comparing what is by far the largest canal, the Nilocertus, with the micrometer thread. From such determination, it appeared that this canal was from 25 to 30 miles wide. But it is questionable whether the Nilocertus can properly be termed a canal, so much does it exceed the rest. It is certainly far larger than the majority of them. For comparative estimates between its size and that of the others, 15 to 20 miles for the width of the larger of the Martian canals seems to be the most probable value, and 2 or 3 miles only of the more diminutive of those so far detected. On the other hand, the length of the canals is relatively enormous. With them, 2,000 miles is common, while many exceed 2,500, and the Eumenids Orcus is 3,540 miles from the point where it leaves the Phoenix Lake to the point where it enters the Trivium Charontis. This means much more on Mars than it would on Earth, owing to the smaller size of the planet. Such a length exceeds a third of the whole circumference of its globe at the equator. But what is still more remarkable, throughout the whole of the long course taken by the canal, it swerves neither to the right nor to the left of the great circle joining the 2 points. Of these several peculiarities of the individual canal, it is difficult to know which to allot the palm for oddity: great circle directness, excessive in length, want of width, or striking uniformity. Each is so anomalously unnatural as to have received the approving stamp of incredulity. Yet so much, wonderful as it is encountered on the very threshold of the subject.
End of section 16. Recording by Michael Knowles, Fort Worth, Texas.